Yes, sir. Yes, sir.
Yes.
Oh, just a minute, sir.
Your yeah, madam. Okay.
Shall we start this? Shall we start? Hello, sir. Hear me, voice?
Yes, madam. I'm audible. It's audible.
Okay, sir. Good morning to one and all present here. On behalf of Excel Engineering College, I would like to welcome our resource person, Dr. Suresh Babu, NIT Warangal. And I would like to welcome our participants. Once again, I welcome you all. I hand over the session to Dr. Suresh Babu, NIT Warangal.
Thank you, madam. Thank you very much.
Thank you, sir.
Madam, my screen is visible. Hello.
Yes, sir.
Yeah. Very good morning to all of you. In the last session, we discussed the role of cybersecurity in a blockchain, which we can make use of blockchain very effectively to resolve the issues of the cybersecurity. Today, we are going to see how these cybersecurity issues can be easily solved using a blockchain that we are going to see. Right. So quickly, we'll try to see. I think if it is already covered by the other resource persons, please let me know. The introduction aspects. I think yesterday when we have a discussion with the introduction part of blockchain, that most of the people are aware of this blockchain, but we need to know how these cryptographic primitives or consensus mechanisms or the smart contract, how we are going to use these properties in the blockchain. That's the biggest question we do have. Okay. So we have to see now the blockchain. The other name for the blockchain is distributed ledger technology (DLT). We already know that it makes use of distributed ledger technology. In the yesterday session, also we have seen the trend is moving from centralized system to decentralized system. So because to make the attack tolerant, I request the participants please mute yourself. Yeah, thank you. Now we are going to see all the records, ledger records, all the transactions stored in the form of ledger records. We are not using any cryptocurrency here. Whatever the transaction or whatever the data you want to transmit over a network or you want to process over a network, we are storing into the ledger so that only a group of people can be aware of that. The next one is the other one is the key value database with the current state. This is a little bit interesting, I think, while you are studying a data structures. Now, I want to ask a question here. All are computer science relevant participants or any other non-CS who are there? Hello. All are computer science? Yeah, then it is okay then.
Hello, sir. No audible, sir.
Okay, the next one is the decentralized peer-to-peer network of nodes we do have, because blockchain is known for a peer-to-peer network of nodes. So that's a very important part. We need to have it because of a decentralized and distributed method. And then you're going to see the public key cryptography without a central authority which you're going to use it. So
Sir,
therefore,
can you repeat it, because there was no audio from this
oh
ledger record of all transactions.
yeah. Okay. So the first one is distributed ledger technology. But the blockchain, the other name is distributed ledger technology. And then we are going to have the ledger records, because all the records, if you want to store any information other than, because we are not interested in cryptocurrency here, we are not interested with Bitcoin. It doesn't require any mining mechanisms here. But we can use for the other applications, like if you want to use a blockchain in IoT, yes, you can provide a lot of identification, distributed identification on authentication can be provided, integrity can be provided. So all the information, see, no, only we are not interested with a single validator. We are interested with multiple validators. Suppose, for example, if you take Excel college is there, and then in that college, the principal will be there. There is no concept of monopoly in the principal. Now, what the principal will do, now, if I want to run effectively this institution, I'll take the opinion of all the HODs. So the HODs are nothing but the validators. So decision maker may be the principal, but all the validators will give the opinion, and they will come to know that what is going to happen in the Excel engineering college. So accordingly, and all the members, like the faculty members, students, or parents, are the members of that. Whatever it is happening, the validators along with the principal, they are going to take the collective decision. So blockchain is going to work such a beautiful way where all the ledger information will be stored by all the validators. That's another point we need to be aware of that. The next one is key value database, because if you want to reduce the computational overhead in blockchain, rather than storing a whole information in the blockchain, we are going to store offline mode as well as online mode. Only the essential information which we can store in the online mode, and the necessary information used database can be stored at the offline mode. So key value database with the current state option which we can store it. The other point which we are interested with the decentralized peer-to-peer network of nodes, which we are interested with, this decentralized peer-to-peer network of node, which is a decentralized one. The which my session is all about, which we're going to discuss in detail about public key cryptography. Right? How many people already know about this public key cryptography? Yeah, Madhu madam knows it. What about the other people? Everyone know about the cryptography, or shall I
Yes,
give some basics of that?
yes, sir. Little bit idea about public key cryptography.
Oh, right. I think then if you want to, So that's a point to be. Even I told you, then everyone see it's not only relevant to the computer science people. The computer science people also there are a lot of specializations were there. Like for example, the specializations may be in the form of data mining. The specialization may be in the form of image processing. The specialization will be in the form of maybe big data. The specialization will be in the cloud computing. The specializations can be in the fog computing. So in computer science also a lot of domains will be there and they will be master in those areas. But if we see in those areas also, one of the major important points that we need to be aware of is the security. If you take it image processing, in image processing, definitely we need to have some security aspects of that, because whatever the data which you
কৃষ্ণদার কাছ থেকে পেয়ে যাবে এগুলো। না, অরূপের কাছ থেকে নিয়ে আনি। হ্যাঁ।
Sir, dear participants, kindly mute your mobile.
This is a problem with online training, right? That's right now we are going to see any transaction is added is validated by the multiple entries which you are going to have it. Therefore, the blockchain is going like a distributed digital trust. Blockchain is nothing but a distributed digital trust. Okay, so that's a point of which we are interested with. Now we'll try to see a little bit interesting one. Quickly, we'll try to see. I think other resource persons already covered this introduction aspect, but if you want to know the concepts in detail, therefore I'm just reviewing it. All the transactions are stored in a ledger in a decentralized manner, so that no one has exclusive ownership or control. No one will have the exclusive or control. See, what is the problem with ownership? But definitely there will be chances of misleading. So no one has no entity has exclusive ownership or control of the records of information or a transaction. That's an interesting property of the blockchain we have. So what we are going to see in refers to the each block is referred to the preceding block which we are going to have it. So this block is referring to this block is referring to the preceding block. This block is referring to the preceding block. So what we are going to see, and the batches of transactions are recorded and it forms a chain. So block and chain, which we call them as what? Blockchain technology. Okay. Now I request the participants.
Hello, sir. Your voice is not audible, sir.
Hello.
Hello, sir.
Madam, I don't know what is the problem in Meet. I think every time it is holding on and voice is breaking.
Yes, sir.
We couldn't hear you, sir.
No, my idea is okay now.
Yeah, now we are able to hear you.
Shall I start now? It's okay.
Yes, sir.
Yes,
We are
sir.
able to hear you.
Now, I request the participants please go through the definition, which even most of the people are familiar with. A single linked chain of blocks of a verified signed transaction. Now, that is replicated globally on millions of nodes if you are connecting. And that's the first point. The second one, each and every block is linked with the hash pointer. Now, I request the participants, what are the cryptographic primitives we used in this definition?
Cryptographic primitives,
Yes.
hash function, blockchain method.
No, blockchain uses this cryptographic primitives. Hash function is one.
Hash function. Okay.
Yes, madam. Any other, madam?
But there is a mode of operation like blockchain mode of operation in cryptography. That's why I
No, that's why we
pointed out
use
that.
cryptographic primitives, mechanisms, concepts in blockchain. In this definition, what are the cryptographic concepts we are using? In this definition,
Hashing.
only hash, madam. Any other?
Message digest, sir.
Message digest, which we will use the hash function itself. Now, if you see, I'm going to sign, everyone is going to verify. I'm going to sign.
Digital signature.
Yes. Someone, Madhav has already written that. You see, signed a transaction. If I'm going to see some transaction, I'm going to sign it. Everyone is going to verify. So how we can do is a linked chain of blocks of verified signed transaction that is replicated globally on millions of nodes. Then each and every block is linked with the hash pointer. So what are the cryptographic primitives we use, especially the blockchain, is one is the digital signature and the other one is public key cryptography. Right, public digital signature makes use of public key cryptography, and then we are going to use hash pointer, hash function. Right, that's which we are going to use the two important concepts. So what we can say, if you want to change anything, you need to change the millions of nodes to attack and to change it. So definitely we can have some protection over our data, when we are using a blockchain technology. Okay. Do you have any doubts regarding this definition?
No, sir.
Yeah. Right. So therefore, we'll try to seek four important key concepts. Maybe some other resource persons have maybe covered distributed ledger technology. If they are covering a shared ledger, how we can use it. And the other persons may use consensus mechanisms, like it's an agreement protocols. There are so many agreement protocols were there. All parties agreed to the network verified transaction. And then we have a lot of smart contracts or chain code. We can call them as in various things where every piece of code will have some embedded code, which is on condition statements will be there. Based upon the on condition itself, it is going to happen. I'll give a small example to you. Suppose, for example, that Excel college has taken the agreement. Agreement every faculty should attend every session. Otherwise, they are not going to get this certificate. That's the rule they have taken. That's the policy they have taken into consideration. Now, then you have signed it, and your principal or respective HODs of your college, they have signed it and they verified it, and they have sent to you for online classes. Now, it is a responsibility of you. If you miss any one of the session, then your smart contract will be invoked and it will be informed. Right, that's a smart contract which we are going to use it. But my session is all about the cryptography, which we're going to use it. Cryptography, how to distribute the keys, how to ensure digital signature, how we are going to perform. That's why ensuring appropriate visibility, the transactions are secured, authenticated, and verifiable. So these are the four properties. Four key concepts is required. Each concept has its own mechanism. So if you want to apply blockchain, definitely these four key concepts are very much essential. Okay. Now, before we proceed to the block, first we'll try to see how to find a block. Now, in the yesterday session, I told you there is one transaction from user A to user B, other transaction from C to D, other transaction from X to Y, other transaction from M to N, other transaction from O to P. So all these things, what we'll do it, We'll try to create each and every transaction, and we'll try to create a block. And this block, what we are going to do, we are going to validate it. We are right. A node is going to validate it with the help of the validator, and then we are going to enter into the chain. And then we're going to enter into the chain. Therefore, this is the way of finding a new block into the chain, which you're going to have. You got it, all of you? Right? Now, we are not using any cryptography. Minor concept is not required. But only thing is, we are going to use some proof of work depending upon the application or depending upon the context, which we'll try to use we can change the blockchain, verifying all the transaction, right? And then we are putting the transaction to the block, and then we are going to have a mathematical puzzle called nonce, right? Whose hash value should start with 4 zeros. That's the concept which we're going to use it and add to the block to the blockchain. That we are going to see into the blockchain concept, which we're going to use it, finding a new block into the chain. Okay. So here, how we are going to transfer a block in this sense? Only you can sign, everyone can verify, you cannot deny. What are the cryptographic services that? What are the services of security? Can anyone tell me?
Consensus algorithm.
No, madam. I'm talking about security, madam. Security. We have authentication, we have confidentiality, right? We have integrity, isn't it? We have another one called non-reputation. Yes or no? Non-reputation. Non-reputation is
Yes,
once you agreed the system, you cannot deny later. Once you agreed the system, later you cannot deny. That's an interesting property we need to have it. So therefore, once you accept any crypto system, you cannot deny later. Because you applied for FDP program, later you cannot deny that I'm not going to attend for this FDP program. So because that's the point we need to have it. Only you can sign, everyone can verify, you cannot deny later, both the sender and as well as the receiver. Right? So these are the properties that we need to apply in the digital signature. Now this I think some of the resource persons may already covered this internal architecture, but it is my if you want to use it. See, that's why if you see the hash of block 0, this is the hash of block 1, this is the hash of block 2, that this is this one and this one will be linked. This is a link, right? And this is the link we have. And this is the link we have. Right? This is a hash of the block 0 and this is the hash of block 1. This is the block 1 and block 2, block 3, like this we can which we can create block chain which we could have. Now, if you see here, this is a complex view of blockchain. It's a very complex architecture we have. Very complex architecture. I request the participant please observe carefully. Do you understand this one? Right, now this is the owner's one public key, this is the owner's one private key. With the help of the private key you are going to sign it, and with the help of the public key you are going to verify it. We are going to create a signature, right? And then we are going to have even the public key hash can be created as one of the identification which we can do it. So this is the way that this is the one block we have, and this block consists of set of transactions which you're going to have. You already know it, all of you?
yes, sir.
Now we need to know how we are going to create a blockchain. Suppose, for example, now if you want to apply blockchain for big data, or if you want to apply a blockchain for something like videos, if you want to apply blockchain for cloud computing, or if you want to apply blockchain for this, now you are not a security expert, right? If you are not a security expert, but you want to apply blockchain, right? Now you need to know about some basic concepts. So therefore, my session is all about how to introduce this basic concept to even a layman, right? Even a non-cryptographic security guy also you should understand. So that's the point. Therefore, we'll try to see that those concepts. Now, this is the internal architecture we have. This is a list of transactions we have. This is a difficult target value, and these are nonce which you're going to have it, and this is a Merkle truth which we'll try to see. It is a binary tree. Merkle tree is a binary tree which is proposed by Merkle. He proposed the SHA series, SHA functions which makes use of that, and then this is a block n plus 1, block n plus 2, like that, and so on and so forth. Okay. And this is a Merkle tree we have. This is a transaction, the hash of this transaction. This is a transaction, this is a hash of this transaction. This is a transaction, this is a hash of transaction. This is a transaction, hash of transaction. These two hashes will be here. These two hashes will be here, and this hash will be here. And this will bring you to the previous chain. This is a chain of blocks which you are going to get it. Okay. This is an example of the Merkle tree we have. This is the data 1, data 2, data 3, and data 4 we have. And this is a hash of data 1, this is a hash of data 2, and so on. These two hashes will be created, these two hashes will be created, these two hashes will be created here. Right, we are going to see in the form of a block which you are going to create. Do you understood, all of you? There's a concept. Any doubt here?
No, sir.
Yeah, okay. Now we'll try to see how we can create, how can we create a distributed ledger work in blockchain. That's the important one. Right? Now, if you see, user is going to initiate the transaction using digital signature, means we need to understand some little bit digital signature concept. And user is going to broadcast their transaction, sign the transaction to the nodes. One or more nodes begin validating each transaction. Then the transaction is going to combine into the block with the other transaction. And the nodes aggregate validated the transactions into a block, which you are going to have it. And the node is going to broadcast the block to each other.
Block అంటే ఒక డేటా ఒక సెట్ ఆఫ్ డేటా ఒక బ్లాక్ all the members who are available on that block.
I request the participants, please mute yourself. Now this node is going to broadcast the blocks to each other. Then we are going to apply the consensus mechanism, whether everyone is followed, everyone is authenticated, everyone is got the same thing. Agreement mechanism need to be there. And then once the agreement is happened, then it will enter into this true state, which will be changed to the prior block. This is a way how the distributed ledger work in a blockchain. Okay. Now we'll try to see, before we go to the hands-on with this cryptographic primitives, I request the participants will do some hands-on approach. Now, how many people were using mobiles? How many people were using desktops? That's a one point I want. Mobiles and desktop or laptop. Yeah, very good. Good. Out of 57, only 2 members were responded. Good. Okay. Okay, good. Right now, shall we do hands-on now? Now, all of you open, because we'll try to see the internal architecture. Then we'll try to go for a blockchain, right? Now, all of you open. Try to check it out. Not. it will work for half an hour only, every half an hour. So therefore, I request participants, please be a little bit fast so that you will come to know. Right, type in the Google. I'll send a link to you. Madhu madam, please unmute yourself. I'm sending one link to you. Please check it out for that. Rajeshwari madam, please. Some sound is coming. Please click on that so that you will come to know. We will try to see. It will work only for half an hour online. So therefore, we'll try to complete within half an hour only. Before we that, we'll go to the we will go to the digital signatures concept. All right. First, I'll to make it interesting. First, we'll try to see the internal concept of blockchain. Then we'll go for the how blockchain will work. Then we'll go to the cryptographic primitives of the blockchain. Right now, all of you, my screen is visible. My desktop, my browser screen is visible.
Yes, sir.
Yeah.
Yeah, sir.
Yeah. Now, all of you type some in Google. All of you type in the Google. Andres, right? A public and private key generator blockchain. You're able to see Andres, public key and private key generator in blockchain. Everyone should get this one. So if we are doing online, I request the participants please respond so that we cannot waste the time, right? We have only 1.5 hour time, so therefore we need to complete the whole session. Whatever.
Yes, sir. We are taking it. Whatever the things that you have given.
No, madam, this one. If someone will tell okay, then I'll proceed next step. Otherwise, it's very difficult to do hands-on. Now you got this one blockchain demo.
Yes, sir. Yes, blockchain demo, public private.
Yeah,
Yes.
you click on that. You click on that. Then you will get this one.
Yes.
You got it, all of you. Then at
Yes,
the right side, rightmost, there are some icons where the menu is there. Keys, signature, transaction, blockchain.
Blockchain. Yes.
Is there no click on the keys? Up to this, how many people have completed? Please let me know. Yeah, very good. Yeah.
Yes, we are there.
The next, again, once again, go open the browser. Then you take Andres blockchain demo. Once again, Andres blockchain demo.
ஐயோ என்ன ஃபாலோ பண்ண சொன்னாருன்னே தெரியல.
You will get this one.
Yes.
You got it, no? Click on that one.
Yes.
Click on that one. Then click on the hash. I'll give 2 minutes of time. If anyone is still doing, please let me know.
So as of now, 3 tabs we need, sir. Linux containers, blockchain demo, and Anders blockchain demo.
Andres public and private key demo, madam, and Andres blockchain demo. 3.
Okay, sir.
Got it now? Now first we'll try to see, right? First we'll try to see how, because even now we required, because I told you public key cryptography is very much essential in blockchain and without any trusted authority. So we need to have a public key cryptography where there is a private key and the public key, right? Which you're going to have it. Usually we are going to use the key length is 1024. If we are using ECC, we are going to use maybe 256 is sufficient, and better. We have a larger key length. Will provide a better security. Now, there's some mathematical concept behind that. We are going to use some interesting mathematical theory which we're going to use in cryptography. There is a relationship is there between the private key and public key. Now, if you click on random, both the public keys and private keys is going to change it. Check it out on that. Now, how you are going to get what that we'll do once we understand this concept.
பண்றீங்களா
Got it?
பண்ணிட்டு இருக்கீங்களா என்ன?
Sir, I request someone is speaking. Please unmute yourself, and you can talk personally. If you have any doubt, please let me know. Right, this is a public key and private key concept which we do have it. Then we'll go to the hash function. You go to the blockchain demo hash. Then welcome to, you type something and you observe carefully at the bottom, hash is getting changed. Welcome to Excel Engineering College. If you observe that, its hash value is getting changed or not? Yes or no?
Yes, sir, it is getting changed.
Right, very good. So that's a hash property we do have. We're going to use, that's an interesting property which we're going to use it. We'll try to see how that hash properties can be applied very effectively, that we can see it here, or we can see it. Then we'll try to go to the signature, digital signature. Digital signature makes use of both the public key. Now, if you know the digital signatures concept, all of you? Or shall I tell one
Yes,
or two? You know it. Now, how we are going to create a digital signature means we are going to sign the signature with the private key, and with the help of my public key. Madhu madam, you don't know about the digital signature, madam?
I have no idea.
Oh, how many people are there like that? How many people were there, so that I can cover that concept now?
Sir, it's better if you tell us, sir, once.
Oh. Okay, before then we will keep that concept aside, this approach. Then we'll give I'll give you simple basics for that. Then we'll come to the interesting part. We'll do hands-on. Now, whereby we use a blockchain, blockchain uses cryptographic primitives. We'll try to see here. Now, see, we use a digital signature that we'll try to see, and digital signature makes use of public key and the private keys. So for initiating and broadcasting the transaction, we use digital signature, as well as digital signature makes use of the public key and private keys. For chaining the blocks, we use the hash function that I already covered those. Now we'll try to see. Why public key cryptography? In this is public key cryptography provide wide solutions to all the cybersecurity issues. Right, and it is widely used. Right, we'll try to see how we are going to have it. Actually, there are two types of cryptographic mechanisms were there. One is the symmetric cryptographic mechanism. The other one is the public key cryptographic mechanism. In symmetric cryptographic mechanisms, though it provides a better solution with respect to confidentiality, but the major problem is how to distribute the same key to the other side. That's a major problem, right? To overcome that problem, they started introduce the concept of public key cryptography, thanks to the inventors of this public key cryptography like Diffie-Hellman and the RSA, Adelman, Rivest. They are the people who contributed a lot to the public key cryptography, and many more people were there for this public key cryptography we have. Now, the public key cryptography is used to solve two issues. One is key distribution problem, which is there at distributing the same key to the other side. Right, that's a point. And then the other one is the digital signature. How to verify that the message is coming from the claimed sender? how you are going to say that I'm going to presenting the PPT. What is the validation? Right? Whether the Suresh Babu is presenting or someone is presenting. Right? How can you come to know that? So how to verify that the message is coming from the claim sender? Claim sender. So two problems which you're going to use it, but we are not going interested with the key distribution because it is out of this talk. We are not using that, but we are using a digital signature. Okay. If I'm going a little bit fast, please let me know so that I can slow down. Now, public key cryptography makes use of two keys. Public key cryptography makes use of what? Two keys. One is the alias private key. The other one is the alias public key. We have alias the user is going to maintain his private key, which means that it cannot be revealed to the outside world. And the other one is the public key, where it is known to the public or group of authenticated. Even Bob has his private key and Bob has public key, right? Now, we are assuming that because the cryptographic primitives will have certain assumptions. Those assumptions like both the public keys have been exchanged. What is the assumption here? Both the public keys have been exchanged, right? Now, what we are going to do, what is the purpose of using private key? What is the purpose of using a private key? The private key is mainly used only by the owner or by the person who has want to send it. It is only known to the owner. Right? And the private key is used for the two purposes. The private key is used for the two purposes. We have is used to decrypt the message. Is used to decrypt the message and create the signature. Used to decrypt the message and create the signature. We have. That's the first step. The second one is the public key. The public key is known to everybody or group of users. Used to encrypt the message and verify the signature. I'll repeat. Private key is used to decrypt the message and sign the signature, create the signature, whereas public key is used to encrypt the message and verify the signature. Everyone got it? Any doubt here?
No, sir, please proceed.
Okay. Now, if you see how the public key encryption will work, we have a plain text or a known text. We are going to use perform the encryption with the recipient public key. We are assuming that both the public keys have been exchanged. Recipient public key. This public key will be will convert using this recipient public key. We are going to convert from a plain text to ciphertext or unknown text, and then we are going to decrypt. We are going to decrypt with the recipient private key. We are going to decrypt with the recipient public key.
Sir, not able to hear anything.
So what we are having the recipient public key and the recipient private key. We have two different keys which we can use it. Now, if you see here in the public key encryption, what we are having, we have a CA, certificate authority. That certificate authority will issue the public key and the private key, and the public key will be sent to the source, right? The public key will be sent to the source, and then we are going to use it here, all right? With the help of the public key, we have a message. With the help of the public key, I'm going to convert into ciphertext, and this ciphertext can be sent out to the other side, where only with the help of the private key only, or the private key or secret key, we are going to decrypt the message, right? So therefore, this is the way the public key encryption is going to work very effectively. We call them as what? Signed certificate with the source signature. The other way. This is a little bit. We are going to do the encryption, and we are going to create the signature. That is out of scope of this one. That we'll try to see in the maybe once we understood this one. You got it, madam? Now it's not audible.
Now it is audible, sir. Earlier it was not. We got it, sir.
Yeah. Now, any doubts regarding this? You understood the concept, Madhavi, madam, and the other participants who are not aware of that?
Yes, sir.
Yeah.
Yes, sir. Please proceed.
Yeah. Now we'll try to see. We'll try to see now. Again, we go back now. Everyone know that how we are going to create a digital signature. We'll try to see now. Now I told you, this is a private key and this is a public key we have. This is a private key and this is a public key we have, right? And then we'll go to the hash function. We'll try to create a digital signature. Now I'll try to create Excel. Everyone do it. Excel Engineering College. Engineering College. Right? Now what I told you. Now with whom's public key, private key we need to sign it to create a signature.
Alice.
With the sender, okay, with the sender private key only we need to have. This is the private key of the sender, right? I'm going to sign it, and then we got the signature. You can try out. Excel Engineering College with the private key with the message signature we have. All right. Then we'll go to the verification. Verification will be done with the public key of the Alice or the sender. Now, suppose for example, if I change E, someone has changed that, integrity is lost, then you will get what? A red color. Little bit red color means the signature is failed. Right? Because someone has signed and it has been modified in the middle, it has been changed. If it is not happened, then we are going to verify. You will get a green color. You check it out, all of you. Everyone got it? Okay. Sheila Rani, madam, please mute yourself. Shall I proceed?
Yes, sir.
Yeah. Now this is the way digital signature is going to work. Next, what we are going to do, we are going to have the transaction. We have to have the transaction. Now this is the transaction of creating the public key of the sender and the public key of the receiver. This is the public key of the sender and this is the public key of the receiver. Please do it so that you can do later if you want to implement any application. Now what I'm doing, I want to send some 1,000 rupees from one person to other person. Now what I'll do is I'll create a signature. I'll sign with my private key to get the message signature. Okay, and then if something has been changed like this, for example, triple line, the verification is going to get failed. Right, that's the beauty of the digital signature. And then the verification is true, verified, successful. This is a transaction we have. Now, like this, we can create multiple transactions. We can create multiple transactions and we can create a blockchain. We can create a blockchain. Everyone got it?
Yes, sir. Sir, how come these keys are same for you and all the users, all the participants must be having the same key, I think.
Yeah, because that is a database they have been created. I'll tell you created once this session is over, once this topic is over.
Okay, sir. Thank you.
Everyone got it? Shall I proceed further or shall I wait?
Got it, sir.
Yeah. Then we'll go to the block. Block is nothing but set of transaction. I request the participants please carefully observe. This is peer A blockchain. This is peer B blockchain. This peer C is blockchain. Means A is maintaining his blockchain, B is maintaining his blockchain, C is maintaining his blockchain. Same blockchain. And you observe that this is a nonce. This is a nonce value we have. This is a random value, and this is linked with the hash value. Whose hash value first 4 digits should be 0. Whose hash value first 4 digits should be 0. And then see the hash value of this one is linked with this hash value. And the hash value of this one is linked with this value. And the hash value of this one is linked to this one. Hash of this value is linked with this one. You're able to see it, all of you?
Yes, sir.
You're able to see it? Yeah, very good. Now, if you just check it out there, right? There's a peer A want to change something. Now, observe carefully. Nonce value and hash value, check it out. Right now, I changed just to only 99. The whole blockchain is changed. The whole blockchain is changed. You're observing? You're trying? That's an interesting one. Now,
what is that nonce, sir?
Nonce is a random cryptographic random generator, madam. A value.
Okay.
This
What message the data where we store the actual data, sir?
Pardon?
Data.
No, I'm not getting you, madam. Please once again.
What are the transactions we made will be stored as a block in a block?
No, madam. A block consists of set of transactions.
Oh,
right?
Can you show me the transactions in that block, sir? How that is being, and before encrypting?
No, you see, this is the one transaction we have. This is another transaction we have. This is another transaction we have.
Feeds that transactions, sir?
No, PA is a node.
Okay. What data where we are storing actual transactions in that block?
Madam, this is a block. This block consists of
Yes, sir, I got
transaction
it.
2, transaction 3, transaction 4. Now, this is a block maintained by user A. This is a block is maintained by user B. This is a block maintained by user C.
Okay, transactions, I'm asking about.
Madam, this is one transaction. You can take any, see, transaction is nothing but any data which you want to store. Suppose if I want to store some information, credential, user identification I want to store. That is a data. That is one transaction. Your Aadhaar card need to store. Your bank account details need to be stored. That is a transaction we have.
Okay, there in the picture TX means transactions, huh?
Yes, madam.
Okay, sorry. Thanks.
Sir, actually, we have a doubt. I think I understood. Each person will have a block. Am I right, sir?
Blockchain,
then
not block.
Blockchain, yeah, blockchain. Then any number of transactions can be in a block, right, no, sir? That is what you are saying.
No, it depends upon.
One transaction, one block.
No, please listen, madam. Yeah, a very good question. Depending upon the context, depending upon the application. Suppose, for example, if you are using permissionless blockchain, then we can create a number of transactions in each block. If you are using permission blockchain, means we are restricting. Suppose we want to create only 10 transactions per block, we go for permission blockchain. Depending upon the categories, depending on the application which we're going to, if you use public blockchain, n number of transactions we can create it. If you are using permissionless, permissioned and private blockchain, where number of transactions will be restricted. You got it, madam?
Yes, sir, we got it actually. Okay, because that was the doubt. Each block have different number of transactions.
No.
That is the reason we raised. Yeah, got it.
So even if we fix to 10, we can have 9, 8. That's not a problem. But we cannot have more than 10.
When do we fix that, sir?
In the beginning of itself. In the beginning itself, the validator. Suppose Excel now, madam is there. Ramya madam is there. She is the coordinator for this FDP. She got the instruction from AICT and principal. Only 120 members should be taken. Now she can't take 121 members. No, already number of participants is 120 only. That is already happened in the beginning of the FDP itself. In the while at the time of creating an application itself, we'll create the number of transactions to be created for each block.
Okay, sir.
Now, if you observe here, now I changed it. Now, what is going to happen once I changed it? I'll change to 99 and see whole blockchain has been changed. Yes, sir. But peer C is not changed. Peer A and peer B I've created. Now I'll try to create the same 100. Right, what you're going to have it. Now everyone should mine it. If you observe the mining concept here, now if you observe here, now we got new nonce value and then hash value will start with 4 zeros. You got it? Everyone should mine it now. Second block has been changed now. It will take some time to get this. If you observe here, it is going to get changed now. Yeah, it is changed. You are observing. And the hash value is also changed, you know. Now this hash value and this hash value will be same. Link. Similarly, everyone should mine it. Now every block should be mined it, and every peer should mine it. So, for example, now I'll give a certain. Now Excel College want to establish that. For example, now one of the participants is he's not attending the session. Now, because now Ramya madam and the Excel College are good enough to give the permission. Now, what the other people will do, other participants, why you are giving certificate even without attending one session? Now, everyone should agree if the certificate should be given. So that's a blockchain. Blockchain will provide a lot of transparency to the participants we have. You are able to follow me?
Sir, can I ask a question?
Yeah, please.
Excuse me, sir.
Please, sir.
Sir, it is a distributed ledger. Suppose if it is hacked, if a particular peer is hacked by hacker, in that case, how to handle blockchain?
See, we have a powerful validating will be there.
Yeah.
One has been hacked, immediately other people will come to know that that person has been hacked.
Because it is illegitimate change, not legitimate change. Someone without knowing.
That's why we call them as blockchain does have the problem. 51% attack is going to happen. Not one ledger. 51 out of 100, 51 people were attacked. Then the long chain will be there. That's a different concept, sir. But one people has been hacked means other people will come to know that person has been hacked.
Okay. Thank you, sir. Yeah.
You got my point, sir?
Yes, sir. Yeah.
Any other doubts?
Sir, whether we can use it for blockchain for privacy, sir?
Absolutely, madam. It is required.
How?
See, for example, now we have suppose, for example, I don't know the college is something. We have NIT Warangal, we have Excel Engineering College, we have Anna University. Like now, what we are going to create, we want to see here in the sense. Now we want to we want to create the privacy between suppose an Excel College and Anna University want to confidentially communicate each other without knowing the information to NIT Warangal. Right, so we want to create a separate channel between Excel College and Anna University, right? And there will be separate channel will be established to the Excel College as well as to the NIT Warangal. Now, if you, within the organization, suppose for example, there is a computer science department is there, EC department is there, EEE department is there. Now we can create a separate channels. Now principal want to communicate only with the CSC and EC people. All right. Now he will create a separate channel between the two departments. The other people doesn't know about what is communicated. Right. Personally, you want to communicate with the other departments. No, you don't want to give the information to CSC people. If we can create such type of environment in blockchain.
They all have to validate, no, sir, transactions, whatever I'm making, that has to be validated by anything.
They will know it. They will know it. Right. The validator will know that this transaction is happening, but they cannot view it.
Okay, sir. Thank you, sir.
Any doubts, madam, from your side? From the
To
participant?
create a channel, sir. How to create separate.
That's the tools which we are using Hyperledger, we are using Corda, we are using Ethereum to create separate channels for each these things, madam.
Okay, sir. Okay, sir. Thank you, sir.
Yes. Shall I proceed? Or any other doubts out there?
So what is permissionless blockchain? Permission blockchain, sir?
Yeah. Like now, see, permission and public blockchain. Permission thing is nothing but for certain applications. Suppose, for example, for certain applications we want to create for certificates, generating academic certificates where it will be known to only very few people. In such cases, what we'll do is we'll try to create a blockchain with permission. Permission means we are restricting number of blocks, and each block consists of certain transactions only. In such cases, we'll try to use permission blockchain. Permissionless means or public means the number of transactions can be like unlimited. We can create number of transactions for each block.
Thank you, sir. Not for validating, sir. It's only.
Now, validating it depends upon different applications, madam. Now, you want to create, suppose for example, if you take it Excel, suppose Excel college is there. Now, Excel college want to create something like HOD and deputy HOD. Right now, one college they will take only HOD as a validator. Other college they will take HOD and deputy HOD will be there. Right, two validators in each department need to be there. Like, if you want to increase the validators, yes, you can increase. That's not a problem. It depends upon your application specific, madam.
Okay, sir. Thank you, sir.
Sir, is it a kind of syndicate or consortium blockchain which you are talking about?
Yes, madam.
Okay.
That comes under permission.
Okay, sir. Thank you.
Okay, madam. Yeah. Yeah. Then Linux container, you opened the Linux container, all of you?
Yes, sir.
Okay. Right. Now, all of you, now we'll try to do using OpenSSL, how we are going to get it. As already told you, just we have seen a message is there. I'm going to sign with the private key, and I'm going to create a signature. And this signature will be verified with the public key to get the message. This is a digital signature which you're going to have it. We have to sign a document digitally, and we'll send a signature as a separate document. Just now we have seen this concept in a blockchain. Yes or no? Yes or no?
Yes,
Yeah?
sir.
Yeah.
Yes, sir.
Right. Now we'll try to implement the same concept in the blockchain which you are going to create it. Now, right now, what we are going to do is everyone knows about the cryptography, no? Public key cryptography. Just now I told you that we'll try to see it. Now, this is a concept which we try to implement in today's session. We have a message. We perform the hash. We call them as a one-way hash, and then we get the digest. We call them as message digest, and then we are going to sign with the help of the private key to get the digital signature. We are going to sign the key with the help of the digital signature. This is step number 1. And the same message will be encrypted with the recipient private key, public key, to get the encrypted message. The encrypted message along with the digital signature, which we are going to send to the other side. This is the other side. We have. Now this encrypted message we have. This is the encrypted message we have. This is the encrypted message which we are going to encrypt, which we are going to get this digital signature. We are going to decrypt this digital signature, verify the digital signature with the sender's public key. We got the digest. And this encrypted message I am going to decrypt with the recipient private key. We got the decrypted message.
This is not audible, sir.
Sir, we are not able to hear you.
Online. Right. Okay. Now we are going to.
Sir, we couldn't hear you anything for 2-3 minutes, I think, sir.
What, madam?
Sir, we were not able to hear you for past 2-3 minutes, sir.
From where you are not hearing, madam?
Encrypted message.
Now
Another side, sir.
This one.
Receiver side. On the receiver side, encrypted
This
message.
one. Shall I repeat this one?
Yes, sir.
Now
please.
we have
lost your
encrypted.
Connection,
That's a problem. Right, we have an encrypted message and digital signature. The digital signature will be decrypted with the sender's public key, and we get the digest. And then we get the encrypted message. We are going to decrypt that encrypted message with the recipient public key, private key. We got the decrypted message. This message and this message should be similar, right? So we are going to perform the same one-way hash, whatever he performed, and we get the digest. This digest and this digest will be compared, right? This digest and this digest will be compared. Everyone got it? I request the participants, please take this screenshot of this one. We'll try to implement today. I think we have a time of 20 minutes were there. You're taken?
Yes, sir, we have taken.
Yes. Now, all of you open container, Linux container, will you?
Do we need to start, sir? I have read and accept the terms and services above.
Yes. You need to start, madam. Accept and conditions, you need to have it. It will work for only. It will work for only half an hour, madam.
Okay, sir.
So we'll try to do a little bit fast so that it will be usually. Now all of you type gedit. All of you type gedit.
All small letters, sir?
Yes. All small letters we can have. Or otherwise, I'll show you.
Yes, sir. We could see that in the PPT. So the same thing you want us to type?
Yes, madam. I'll tell you. All of you type this statement now. Echo. You're following me, madam?
G edit we need to delete.
Delete, madam. Please delete it. So G edit means again we need to store. It will the other people who are not comfortable. It will be there. Echo.
$sign should be written, no, sir?
No, madam. Dollar sign will be there actually. Hash symbol will be there. Echo.
Yeah, it is there.
Welcome to right something Excel college or FDP program. Blockchain BCP FDP program. BCT FDP program. Right? Greater than symbol. Plain text. Try to keep all small case only so that you will not be confused. Plain text dot txt. Everyone complete it? So please unmute yourself and can respond so that we can do a little bit faster as well
Yes,
as.
sir. Sir, do we do it in within quote because you have written it
It's
in
not
within
opening in our.
In mobiles it is difficult, but in desktops and laptops it will work, madam. I think.
Server is full.
Server is
Full. Server is currently full. Please try again few minutes.
okay, madam. You can try, but you can take the screenshots of this and later you can try it. That's not a problem.
I got the same message, sir.
Okay, sir.
Right, and then you can type cat space plain text dot txt. Cat space plain text dot txt. Welcome to the BCT FDP program. This is the text we have in that plain text dot txt. Yes or no? Shall we go now?
Yes.
So second statement, second sentence, I need one more, sir, please.
Please see. You got it now?
Yes, sir.
Right. Now, quickly we'll try to see how to create the public key and private key algorithms. Now, this is a statement now. Open SSL. All of you type it. Open SSL. If I give right open SSL, I'll put in the chat box. You can copy and you can paste it. Got it now? The text which I send it. Actually, you need to type, then only you can remember a lot.
Sir, sorry to disturb you. I have small doubt. Sir, if we have done any mistake instead of comma or full stop we have done, how do we need to go back to that particular place and change it?
Upper arrow, back arrow, back arrow. Back arrow is there, no?
Yes, sir. Okay.
Yours. This is open SSL, generate key algorithm. We are using RSA algorithm, key options. RSA generating bits 2048. RSA exponent is third. We are generating the private key A.PEM. Over. Hello?
No, sir, I couldn't. So this open SSSL, okay, where do we need to paste it? The same terminal?
Terminal, madam, terminal.
Sir, is that command is case sensitive? I have to put
Yes, case sensitive, madam.
privacy
Case
caps
sensitive.
to.
Case sensitive.
Okay, okay, sir.
Because that command I couldn't paste it on the terminal, sir. I don't know
No,
why.
it is not accepting because it's security enabled. No, it is not accepting online. Copy.
Okay. So only you will
That's
be
the
able
reason I
to
tried
do
it.
so.
Do it. You need to do it.
Okay, okay, okay. We need to type it, you
Sir,
mean to say.
yes.
Once it is over, please let me know. I think time is not permissible to do hands-on. I'll give the steps to you so that you can take the event
Sir,
today.
okay, sir. Sir, I got some plus and into marks on my
Yeah,
screen.
then successfully completed, madam. If you get like this,
Okay.
you are successfully done it.
Okay, okay.
Now means generated the private key, right? You generated the private key.
Yes.
The next step is now you type that the cat space private key a.pem. Take the screenshots to all of you. You can do later step by step so that you can know how to generate the private key.
Sir, will you share this PPT with us, sir?
Yeah, I'm going to share, madam. But only thing is, please, if you are reusing this PPT for some other purpose, please acknowledge it. Even I told to the coordinator.
Sure, sir. Sure. Definitely. Okay, we will do it.
Because I have seen where I shared because they claimed that this is their PPT. I did my PPTs hours together and I prepared it, but few faculty they are claiming that it is their PPT. And one of my students called me that sir they are claiming their PPT. That's a very bad practice. So
Yes, sir, I understand, but
sharing
definitely we
that.
will acknowledge. Yeah.
If you are using, you can use it because it is not the property any these things. If you are using, just an acknowledgement is essential and it is expected. No. This is the second step. The third step, which we are going to, this is a key which you are going to get it. This is a key, private key. Like you asked me a question, no madam, we can create different types of keys for that particular application, right? Once we get the key, and this is in the hexadecimal format which you are going to get it. And this is the next step which you're going to generate the public key from the private key. We are pulling out open SSL, P key, private key A, public key, pub out. Now this is the public key which you are going to create from the private key. This is the public key which you are creating from the private key. You can do this step. Okay. Shall I, madam? Shall I go?
Yes, sir. It takes time. Please proceed, sir.
Yeah. Now what we are doing, once we create the public key, this is the public key and previous one is the private key, right? So once we created the public and private keys, and then similarly we can generate for user B, that is for user A, and this is for user B. Now you see the same concept, but we changed what? Private key user B, right? For A we have created previously, and for B we are creating. And similarly, what we are going to do, we are going to create the public key for user B. This is a concept where we can apply for which application you want to create. You need not to be expert in cryptography. We are going to use those concepts in our concept. We can use these cryptographic primitives in our concept also. Once we created, we need to have a private key A, private key B, public key A, and public key B. The process which you can do it on your own also. That's not a problem, right? Once we created, now we have already created. Now we need to create a digest. Now all of you you can do it now in the hands-on itself. All of you open the container, type open SSL. Everyone can do it. Open SSL DGST minus SHA1 plain text.txt. Got it, all of you? You're trying it?
Yes, sir. We are trying.
You check it out. Open SSL DGST minus SHA1 plain text.txt. Okay. Similarly, you try it. DGST with 256. 256.
Sir,
Madam.
DGST and then minus SHA1.
SHA1, SHA1. Secure
What?
hash function. SHA. Secure hash algorithm. You type it. Then you get the 256 length plain text. Same thing, but the text is changed. Similarly, you can do it for 512 also.
Oh, that means this is the hash code of the corresponding plain
Code of
text,
your plain text,
right?
madam. Yes.
Yes.
This is a 512 SHA hash code. Same plain text, but hash code length is getting changed to increase more security. You got it, madam? All of you are doing?
Yes, yes, sir.
For the rest of the things, I send the PPT. You can practice step by step. Where you can do it on. You can verify these cryptographic primitives. But because of the time constraint, I'm unable to tell the some hands-on approach. That's it from my side. If you have any doubt, please let me know.
Okay, sir. Dear participants, can anyone give feedback for this session?
Yes,
Madam?
ma'am. Yes, ma'am. This is Dr. Sangeeta from Christ University, Bangalore. This session was very good, actually. We could learn many things because I, from management background, was interested in learning this blockchain technology, but the coding and the algorithm always have a different meaning for me. Okay, when I look at from management perspective, but sir made it very simple. I think I have got the confidence that we will be able to by practice we could get the concept, because my specialization is banking. I'm interested in linking these two, banking technology and the banking and blockchain technology. So sir has actually given a good hands-on. Definitely all the participants would have got the basic of it. Okay, we can't have the hold of it because we need to practice more. I wholeheartedly thank the organizer as well as the guest for this opportunity. Thank you.
Yes, ma'am. Any others? Sir or madam? Participants? Yes, sir or madam? Give feedback. Okay, sir. Uh, thank you.
Yes, madam.
Suresh Babu, sir.
Yes, madam. Yes, madam. Please.
Thank you, sir. Thank you very much.
Thank you, madam. Thank you, one and all.
Valuable session, sir.
Yes, yes, madam. Thank you very much.
Thank you, sir.
I thank each and every participants for the wonderful interaction, because even I felt very happy to each and every participant because they are responding. It will give a lot of pleasure, because when we are interacting and when we are learning something, even for the teacher, it's good to have. Because I thank each and every participants, and especially the coordinators for inviting me to share my knowledge. I once again thank each and everyone. Thank you very much.
Thank you, sir. Thank you. Yeah, thank you. Ma'am, will we get the feedback link?